Hello, everybody, and welcome to the podcast on the metric system. Please try to contain your enthusiasm. I know you're just thrilled to be learning about this. So, as I said, it's the metric system, or why are Americans so stubborn? We're going to talk about why Americans are so stubborn. I don't know if it's more stubbornness or just laziness. So, why the metric system? It is way easier to use than imperial units. You would think that since Americans are so lazy that we would love to do the metric system because it's a lot easier to use than converting feet to miles, miles to yards, pounds to slugs. Yes, there's actually a unit called a slug. It's easier to use because it goes by multiples of 10 rather than some weird measurements. The term foot, the 12 inches that we call a foot, was actually the measurement of some dead king's actual foot that he put inside of his boot. Like, his foot was 12 inches long, and so everybody uses 12 inches as a foot now because of some, dead king's smelly foot. The only three countries that still use those British imperial units exclusively are the United States of America, Myanmar, and Liberia. Some countries still use certain units, like some countries will still use gallons instead of liters, or they'll still use miles instead of kilometers, but in general, everybody uses the metric system except for these three countries. Here's a weird French name. I'm not going to try to pronounce it, but in science, we just call this the SI units. This is actually a place in France, this Système International des Unités. Close enough. But it's actually a building in France where they have like a standard meter, a standard kilogram. They just have this stuff sitting in glass, and that's how we base our meters and kilograms and stuff on. So sometimes people call these SI units MKS units. Math kills students. Not really, but easy way to remember. M is for meters. K is for kilograms, S is for seconds. Now in physics, every time I give you units, you want to make sure you put it in these three units. If I give you something in kilometers, you're going to put that in meters right away. If I give you something in feet, you're going to put that in meters right away. If I give you something in pounds, you're going to put that in kilograms right away. If I give you something in hours, you're going to put that in seconds right away before you do anything else. That's why we do the dimensional analysis. You can convert this stuff because you want everything in your problem to be in MKS units. Sometimes you'll also hear CGS units. These are centimeters, grams, and seconds. And that's just a little trivia for you if it ever comes up on Trivial Pursuit or trivia night at some local pub. Now, in physics, I'm not going to make you remember all of these things, but I am going to make you remember several of them. And by remember, I mean you're going to memorize these because I'm not going to give you these conversions on a test. You're going to have to remember tera and giga. For you computer nerds out there, these first four right here, tera, giga, mega, kilo, those should all be familiar. Terabytes, gigabytes, megabytes, kilobytes. I bet you some of you have a 2 terabyte external hard drive at home or something. I know I do. So tera, it stands for 10 to the 12. Which is a 1 with 12 zeros after it. That means, if we're talking about computers, 1 terabyte is 1 billion bytes. 1 gigabyte is 1 million bytes. I'm sorry, I got that backwards. This is 1 trillion bytes and 1 billion bytes. A mega is 1 million, and a kilo is 1,000. So there are 1,000 kilobytes in every single byte. Now here's your base unit down here. This base units examples: meters, seconds, grams. It could also be weird units like newtons or pascals or some other weird kind of crap. Now down here on the lower end of the scale, we're going to make you memorize centi, milli, and micro. So 7 out of all of these you're going to have to remember. If I'm asking you a question on a test or quiz about something else and I have nano or pico or femto, I'll give you those units. Nano is pretty easy though. Nano 9 times 10 to the negative 9. So micro, the only one It's the only one that's kind of weird. Like its symbol right here is a mu, the Greek letter mu. And what this times 10 to the negative 6 means is that in every one, let's call it meters, every 1 meter, there are 1 times 10 to the negative 6 micrometers. So that also means that there are 10 to the 6 micrometers in 1 meter. Got that? A little confusing. Do some problems, work with it. And here's a problem right here. So, if I want to convert 3.4 meters into micrometers, why am I doing this? I don't know, but I'm sure I can think of something. So 3.4 meters, we want to convert this into micrometers. So since we're all experts at dimensional analysis, we do this. Meters on bottom, micrometers on top. Cancels out the meters. Now 1 meter, there are 1 times 10 to the 6 micrometers. You can also do this as 3.4 meters, and in 1 micrometer, there's 1 times 10 to the negative 6 meters. Okay, so either way you do this, you're going to get the right answer. Probably gonna wanna, back. Yes, I do for now, but that's what I was looking for right there. So then you break out your handy dandy calculator. You want to turn that guy on. And we're going to do the top one. We're going to do this guy right here in your calculator. So 3.4 times 1. Now instead of hitting times 10 to the 6, we're going to want to hit this second button and look for your double E. That E right here literally means times 10 to whatever. Times 10 to what? Times 10 to the 6 for this guy. So you can see here that there are 3,400,000 micrometers in 3.4 meters. So we're going to write that guy down. 3,400,000 micrometers. I don't like all these zeros. Zeros are bad. You want scientific notation. So there's a decimal point right here. Move it 1, 2, 3, 4, 5, 6. Place it to the left. So we can write this as 3.4 times 10 to the 6 micrometers. If you do this guy down here, you get the same exact thing. Now we want to convert centigrams into nanograms. So 7.62 centigrams. We want to convert that into nanograms. But it can be kind of tricky going directly from centigrams to nanograms. So the tried and true method that will never let you down, you want to convert to your base unit first. There are 100 centigrams in 1 gram. So your centigrams are gone. Now we want to go from grams to nanograms. And in 1 gram, there are 1 times 10 to the 9 nanograms. Plug it in your calculator. 7.62 divided by 100 times 1. Use that E button, it's your friend. And you get a lot of nanograms. So let's see, that is 76,200,000. So you get 200,000. Again, we don't like all these zeros. Scientific notation, 7.62. How many? 1, 2, 3, 4, 5, 6, 7. Times 10 to the 7 nanograms. Last example, we're going from 42 gigaseconds, 42 gigaseconds to milliseconds. Now again, you want to convert to your base unit first. Don't get yourself all confused with all those exponents unless you're really good at scientific notation and exponents. So gigaseconds, in 1 gigasecond, there are 1 times 10 to the 9 seconds. And in 1 second, there are 1,000 milliseconds. So you can see here, gigaseconds are gone, seconds are gone, left with milliseconds. Bust out a calculator, 42, because that's the answer to life, the universe, and everything, times 1, your little e friend, 9, times another 1,000. And luckily, when numbers are really freaking huge, it already gives it to you in scientific notation. So it gives you, it gives you 4.2 E13. Get rid of that E though. E is only for calculators. So 4.2 at E, remember, means times 10 to whatever number is after it. So 4.2 times 10 to the 13 milliseconds. Why do we use scientific notation? Because if we didn't, it would look like this. $42, there's your millions, there's your billions, there's your trillions. That's a lot of zeros. You're bound to miss one every once in a while, so put it in scientific notation. That is all. Thanks for watching.